Lab 3. Examples using TensorFlow. The goal of this lab is to familiarize with the different types of tensors and commands that we have in TensorFlow. This is a basic program with TensorFlow which will print you "Welcome to TensorFlow." The first line over here is an import statement which you have to have in all the TensorFlow programs that you will be programming hereafter. So this is the import command which will import TensorFlow as TF. The second line is to create a constant of. So this is something like a constant value. Okay, so this line will create a constant of welcome TF which will have the contents welcome to TensorFlow. This is added as a node to the default graph which will be created when we have a TensorFlow program. So now to execute this particular op, we have to have a session. In TensorFlow, all the executions happens only within the session. So all the outputs of the execution, everything will be contained within the session. So to launch a session, this is the command session is equal to tf.session will launch a session. After that, we will have all the ops that we want to run using the command session.run of welcome tf. Remember, this is the op that we created before launching the session. So remember, all the ops that you've created before your session has to be executed once you launch the session, and this is how you execute your ops. Okay, so now let's run this and see. Okay, so that printed welcome to TensorFlow. Example 2. The objective of this example is to familiarize you to the different types of tensors that can be used in TensorFlow. So these are the different types of tensors that we have here: constant tensor, random tensor, variable tensor, and placeholder tensor. So constant tensor is a tensor that deals with constant values. The random tensor is that which deals with values that are generated randomly. Variable tensor is a storage tensor, and placeholder tensor is a tensor that should always be fed while executing the program. So I've used most of the tensors here in this very basic program. So the first part, that is value underscore a equals tf.constant of 5, will create a constant tensor. Const a is equal to tf.const of 1, 2, 3 will again create another constant tensor with these tensor values. This is a scalar value and this one is a vector one. Okay, so this line will create a node called as product with the operation tf.mul. That means it takes care of the multiplication operation. Okay, so for the node product, I have defined the operation as multiplication, and multiplication is done between the values value underscore a and const a. Okay, so these two are constant tensors and I'm doing a multiplication operation here. Okay, so in the next part, I'm using a variable tensor for value underscore b. So what's special with a variable tensor is that these are storage tensors, which means it will hold the tensor value that you wanted it to hold. But initially, when they are created, these variable tensors are initialized with zeros. irrespective of what you really wanted it to store. So variable tensors are always associated with the initialization command that we have here. So once you launch your session and you run this command using that session, you can have your value underscore b. That means your variable tensor initialized with the value that you really wanted it to be initialized. Okay, so I have used gf.square of value underscore a. Value underscore a is nothing but 5 in this program, so this will get me 5 cross 5, 25, and value underscore b will be populated with 25 once the initialization command is run within the session. Okay, so in the next line I'm using a constant tensor, as we can see here. So with this constant tensor, what I'm doing is I'm creating another node and I'm defining the operation of addition here, and the addition is between the variable tensor and the constant tensor. So now you can understand that you can even do an operation between these different types of tensors as well. Okay, in this line I am creating a node mat prod1, and I'm defining the operation of matrix multiplication between the constant tensors const b and const a. Okay, here I am using the placeholder tensor. So how I can create a placeholder tensor is by using the arguments dtype, shape, and name. Shape and name are optional arguments, but dtype is a mandatory one. So when you specify the dtype, which is the type of the tensor values, this means that the type of tensors that should be fed into PL holder tensor should be of type float. Okay, so what I'm trying to do here is I'm trying to use the tensor which is there in this placeholder tensor and do a transpose operation. So within the node mat trans, I have the operation tf.transpose on PL holder tensor value. So in this line, I am launching a session. This is another way that you can launch your session. Within the launched session, I am running the initialization command. So that means my variable tensors are going to be filled with the values that I really wanted it to be filled. The next line, it will execute the matrix multiplication command, and in the following line it will execute the transpose command. So here you can see something called as feed underscore dict. So this is associated with the placeholder tensors. You must always initialize your placeholder tensor values with a feed underscore dict argument that comes along with session.run command or tensor.evaluation command or operation.run command. So for in our case session.run, we're using feed underscore dict to populate our placeholder tensor values. So on the execution of this line, the placeholder tensor values will be initialized with the values that are specified here, and it will be used to calculate or to get the transpose of the metrics that I've provided there. Okay, so now let's run this example. So we have the matrix multiplication output here, and the transpose of my placeholder tensor is also shown here. Example 3. Objective of this example is to use tensor commands to help you access elements within a tensor and also to get familiarized with rank, shape, and types that are used to describe a tensor. So in this example, I've got three constant tensors here of varied type, rank, and shapes. So this is an example of rank 2 tensor. Value C tensor is an example of rank 3 tensor. To describe it in terms of shape, value A is of shape 1, 3 because it has 3 elements and shape 1. Value B is an example of 3, 3 tensor because it has got three sets and each set with three elements inside. And value C tensor is an example of 1, 6, 3 because we've got six sets here, each set having three elements each. Now to obtain a part of this tensor, okay, that is to slice a tensor, we can use the command tf.slice. This command has to be used with three arguments. The first argument indicating the tensor to access, the second argument indicates the dimension or the set number that you have to access, and the third argument indicates the number of vectors to be accessed followed by the number of elements that has to be displayed on your output screen. So here in this example, value a comma 0 0 means it will access the very first set. Yeah, you've got only one set here. And the third argument says 1 comma 3. So 1 indicates the number of set to be obtained, followed by the number of elements from that set that has to be displayed. So here this will display 4, 6 and 8. Whereas in the case of value B tensor, it says 1 comma 0 on your second argument. So that means it will not see this set. Instead, it will start with this set, the second set. Okay, so it starts with 1 comma 0. So that means the second set, followed by 2 comma 3. That means this 2 will give you the number of sets from the second set. Okay, so that means it will access the second set and then the third set because it was 2, and 2 is followed by 3. So that means it will give you all the three elements from these two sets. Okay, so now let's run this and see so then it's more clear. Okay, so as I said, for value B, it has got you two sets, each set with all the three values. Now let's go back to our program. Let's try to edit this and show you how to access maybe just two values from it. So if I give 2 here, then that means it will just take the first two elements from these two sets. And why am I accessing these two sets? Because I've mentioned 2 here in the first element of my third argument. Okay. Okay, so it has given me two values. Example 4. In this program, we are primarily focusing on how to generate a graph using TensorBoard. So this is a program which does a set of computation on a random set of values. So to give you an idea about what is happening in the program, I have an input placeholder tensor value of type float and of shape 1, 3. This is followed by three hidden layers which contains my weight variable tensors, my bias values, and these two values are used within my sigmoid layer, which does a matrix multiplication between the input tensor and the weight. To the weighted input values, I am adding the bias value and is fed as input to my sigmoid layer. So once this is calculated, I am using this in my softmax layer. So softmax layer has got its own weights and biases initialized as variable tensors again. So it again does the matrix multiplication between the sigmoid out received in the previous layer with the weights generated in the softmax layer. The matrix product is then added with the bias value of the softmax layer. The result underscore layer is used in the softmax function. It is used as an argument with the softmax function to get the output from the hidden layer as softmax. Now, this is followed by calculation of cross entropy using the function softmax cross entropy with logits, which uses the result obtained from the hidden layer and the result placeholder tensor, which is created here. This placeholder is going to be fed with the target result that we would like our program to predict. So that is fed in my session.run command over here. So since they are placeholder tensor values, they are fed using the argument feed underscore dict. Once the cross entropy value is obtained, we do the training process, that is using the gradient descent optimizer algorithm, and we get the train underscore op node. The tf.scalar underscore summary is a function which would collect all these scalar summary ops that will contain the learning rates or the loss that got calculated while running this program. The tf.merge underscore all underscore summaries will collect all the summaries across the ops and it generates a summary data. In the following line, we have the train.summary writer, which will generate a log directory, mnest underscore logs, which will contain all the summaries and the events that got created while we run our network model. So now let's see how to generate the graph using tensor boot command. Let's run this now. This was compiled successfully. So now let's run the tensorboard command this way. There is tensorboard -- log directory and temp mnest logs. Run this and let's navigate to this address mentioned here. So what we do is we will open our browser page and type this address with your server IP address. So I've typed my IP address :and 6006, and in graphs I'll find my graph generated for the program that I just executed. So as you can see here, I have the namespace base and bias used in sigmoid layer followed by the softmax layer. So if you remember, in our program we have got 3 hidden layers. So these 3 indicates the 3 layers and how the values were used here and there to calculate the output. So from the 3rd layer, it is calculating the entropy followed by the gradient value. So unlike the other boxes, here it's a small circle which indicates a node. So here in the program, if you have more than one operation defined for a particular node, that will come as a rectangle. On the other hand, if you have just got one operation defined for a node, you'll see it as an oval. So that's what you're seeing in the graph here. You have only one operation for the entropy, so you have a node, whereas all the others we have more than one operation defined, so then hence we have a rectangle generated.